Alright, boys and girls, welcome back to the drive-through. Hope everyone's having a great day as we move on in through Chapter 1 of Algebra. Here we go. You'll get the idea, but we're just going to do a whole lot of these. This is something that we need to be good at in math, so let's take a look at this example. Notice that here we're starting to be giving a zeroth term. Remember that that is your y-intercept. Where here, since this is arithmetic, it goes up by 3, up by 3, up by 3. That is your slope. And that's going to be the key to these arithmetic ones. I can tell you right now, the geometric ones are going to be harder. So we're going to have to look for a good pattern here. So, how do we find the next term? We add 5. The recursive rule. Well, f of 1 is 5. F of n is f of n minus 1 plus 5. I know that still doesn't mean a whole lot to you guys, but hopefully you're getting more comfortable with that. It'll help your programming minds down the road. Okay, to find the nth term. Well, let's see what our y-intercept would be. So if we had a 0, we follow the pattern, our y would be 0. So this is our y-intercept. So start at 0, add 5 n times. Okay, so what's the explicit rule? F of n, well remember, this is y equals mx plus b, or f of n equals m times n plus b. Okay, same thing. So, what is our slope? Our slope is 5. And our y-intercept is 0. Okay? And this is arithmetic. And now we're going to go a little faster. Okay? For each one of these, I would suggest that you find what the y-intercept is. So here the pattern is, let's see, it went down 9, down 9, down 9, down 9. So if we went up 9, we would start at 1. Okay? And we subtract 9 to find the next term. The recursive rule, well, f of 1 is negative 8. F of n is f of n minus 1, and then minus 8. Okay? To find the nth term, start at 1. Subtract 8n times. Okay, the explicit rule, that's y equals mx plus b, or f of n equals, what's our slope here? Our slope is negative 8, and our y-intercept is 1. And again, this is arithmetic. How do I know it's arithmetic? Because it's going down by 9 every time. It's linear. It has a slope. Okay? Function C, now we're multiplying. We have a common ratio. We're multiplying it by 3 every time. So to find the next term, multiply by 3. The recursive rule, f of 1 is 2. F of n is f of n minus 1 times 3. To find the nth term, this is 2 times 1, 2 times 3, 2 times 9, and then 2 times 27. Okay, well, this is the same thing as 2 times 3 to the 0, 2 times 3 to the first, 2 times 3 to the second, 2 times 3 cubed. Notice, 1 goes to a 0, 2 goes to a 1, 3 goes to a 2, so I think the nth one will lead you to 2 times 3 to the n minus 1. Okay? So that's going to be the explicit rule. F of n is 2 times 3 to the n minus 1. To find the nth term, I'm just going to write that, because that's what that means. And this is geometric. Give myself a little more room. Okay. So again, the first one is 3. The second one is 15. The third one is 27. The fourth one is 39. Up 12 of 12 of 12. Nice. To find the next term, add 12. Recursive rule. F of 1 is 3. F of n is f of n minus 1, so it's f of n, it's f of the last term, and then plus 12. Well, we need the y-intercept, so if we put in a 0, what will we get? What's 3 minus 12? A negative 9. So that is your b. This is your m. So you could write it as y equals 12x minus 9, or we can write that as f of n is 12 times n minus 9. Same thing, that is the explicit rule, so that's kind of redundant, and this one is arithmetic. We've got more to go through. Lines. All right, here we go. Okay, notice 1 3/5, 1 6/5. So keep in mind, this is 5. This is 8/5, 11/5, 10, 14/5, 15 and 17/5. So if you notice, you're adding 3/5 every time. Adding 3/5. So let f of 0 or f of 1, it doesn't matter, as long as we have one starting point. F of 0 equals 1. F of n is f of n minus 1 plus 3/5. Explicit rule, let's see. This is your y-intercept. So f of n is 3/5 n plus, we start at 1. This is our b, and that's our m. And this is arithmetic. Add 1, add 3, add 5, add 7, add the next odd. Wow. I can do this. F of 0 is 3. F of n is f, here, let's just write it over here. F of n is f of n minus 1 plus 2. Let's see. Nope. Plus the previous odd. So let's see. Okay, so this is a real challenge, but I think you're adding 2n minus 1 every time. After 0, we added 1. No, it's 2n plus 1. Okay, that's hard. To find the nth term, well, this is going to be n squared plus 3. So look, 0 squared is 0 plus 3. 1 squared is 1 plus 3. 2 squared is 4 plus 3. So f of n is n squared plus 3. We're going to learn more about that in the future chapters. And this is neither. It's quadratic. Okay. Here, to get from 10 to 2, we either subtracted 8 or we multiplied by 2/10. If we multiply 2 times 2/10, we get 4/10, which is 2/5. Multiply by 2/10. Multiply by 2/10. Multiply by 2/10. So to find the next term, we're going to multiply by 2/10 or 1/5. F of 1 is 10. F of n is f of n minus 1, the previous one, times a fifth. To find the nth term, well, let's see, the 0th term was 50. So let's see. That is 1/5. So just like some of the recent ones, the explicit rule is f of n is 10 times 1/5 to the n minus 1, and that is geometric. Whew. Boom! Oh no, we got another one. A fake boom. Alright, so here we multiplied by -0.2, and then we multiplied by -0.2, and multiplied by -0.2. So let's just go fast on this one. This is geometric. Multiply by, or multiply, whatever notation you want to use, -0.2. We can do the recursive rule. We know that. Let's do the nth term. Alright, so where do we start with? We start with -1 times -0.2 to the n minus 1. And that should get it done. So f of n is -1 times -0.2 to the n minus 1. And you do need both those negatives. It's not the same thing as 0.2 to the n minus 1. Tough stuff. Seriously this time. Boom!